I think the bells are turned off right now. I told you you're good to go.
Did you just read it? The one with the key
Really?
Yeah, no, I'm just reading. No, I don't understand anything that's in there.
Yeah, it's calculus joke.
Mr. Townsend,
Yes.
what did we do on Wednesday last week? I had a college visit, so
That was so funny.
You're gonna need to watch the class recording to get the new information.
what?
Class recording?
I have not looked at it.
Okay. Yeah, you need to watch that to get the information.
Okay. Are there any papers I need?
8 pounds of bird. No.
Okay.
The class recording is gonna tell you what you need. You're gonna have to watch that anyway to get the new information. So.
And they were both.
But the handouts will be in that basket over there. Which ones you need?
I had one of the goose eggs was from here, and there was a lot of.
It was so big.
Dude, it wasn't that long. maybe 20 minutes after shooting night, but maybe an hour and a half after shooting.
It was like an hour and a half. Oh.
Are you done? Yeah. I mean, I'm gonna work out. I just think they're
I'm sitting here holding this. No flashlight. Our phone was dead. I didn't even have a phone flashlight. I was holding the freaking sled in the water.
She'll get off your back of that junk survey. I'm so glad that you saw that. Sorry. It was every second. Lydia, jump, Lydia, jump, Lydia, jump. I was like, you're not talking about anything else. Lydia,
Hey, do I get one? Bring it us
They're my silhouette.
So I could have not brought them with me.
are you still?
I'll let you use them.
I would talk to her. Because I think she thinks you are.
Yeah.
Hey, cool. You don't practice, you don't play.
I'm me
I
on
don't care. I still practice, not allowed to play.
We had 4 Mallards.
You know I'm gonna talk. Fouls just turn the ball over.
Yeah.
Fouls not an educator. Fouls, there's no way.
Robert, you think you can argue? They don't plan. It's me.
I put it on the scale.
Goose did not want to
I put it on the scale.
They suck.
Nah.
He's like 6'5".
Yeah, I am.
He's locking up lost.
Is it Tyler Clark?
Yeah.
Oh, I got that.
Cole, what happened to your
You're not going
What's
to.
that from that?
Algar lost.
What man?
I should have put a read on Tyler Clark.
Look, it's like you.
Lawson Blake.
No. Yeah, we're playing Lawson Blake in the intramural basketball.
Oh, guess what I saw yesterday?
Who?
Me and Landon dropped home.
No way.
Yeah.
Where?
I saw her at a freaking gas station.
Hold on, let's
Take a shit.
Hey, last I drew up 5 plays.
Landon,
Bro, I don't care. I'm playing. We're going to Miles House.
I'm running point guard.
It's me, Trace Reed, starting 3.
Your situation.
Me, Miles Reed, starting 3.
I'm going to the cat.
Doesn't matter.
You're so funny.
Miles?
I'm starting. He's the best player on the team, and I'm starting.
Miles is starting.
Yeah, well, I'm starting
The
over
best
Miles.
starting 3 is Lee.
There's no way I can do this, Miles. Miles will fight me to the death to start.
I'm playing.
I don't care that much, so I think I'll just sit through this.
That was crazy, but I want to play. He was going to a cheer competition, Portsmouth. No, in Rogers. Yeah. Yes, we're talking.
Caroline.
Really weird.
Corn. Apparently she was.
All right, guys, we need to get started here pretty quickly. We do have a fire alarm scheduled for sometime this afternoon, and that never happens during third period because third period has lunch attached to it. So I don't know if it's going to be this period or seventh period, but to try to get you to not have homework, we need to get started just in case. So we're going to continue on with limits. So I'll give you a quick reminder. Day one, we talked about what a limit looks like from a graph and table. Day two, which was the last time I saw you, we talked about direct substitution and indeterminate form 0 over 0 and how to deal with that with factoring. Today, day three, the new piece is going to be, we're going to deal with indeterminate form in two new ways. And then I'll have you practice some skills from that first day so that you don't forget those.
We were shooting.
Okay, so last time we dealt with 0 over 0. Guys, please get settled in here if y'all can't handle your seats. I know I've threatened this before, but I need y'all to be able to start when class starts. I'm not going to compete with you. Okay, so the first two are just a quick little reminder that we're still starting off with direct substitution. That's still going to be the first and last step. So try to plug it in. Hope that you get a real number, because if you get a real number, you can be finished. There are times where if you skip that step, you're going to do a bunch of work to get the wrong answer, whereas this is supposed to be the fast way. Plugging in 0 here, dividing by 0 gives you undefined fraction, which makes your limit does not exist. So I said that last time, I just reminding you because that's a common one to forget about. And then also, like last time, when we try to do direct substitution, if we get 0 on top and 0 on bottom, this is still going to be called indeterminate form. We just need to practice two new ways, two new tools on how to deal with that. Right now, the only way you know to deal with that is factoring. But of course, if you look at that question, neither the numerator nor the denominator factors. So that's what we learned last time is not sufficient for this. So same question down here. So I'm just going to work it out down here. So the trick to this question type, if you get 0 over 0, is I see that I've got a square root here. And so we are going to use conjugates as a way to make this look different to make direct substitution work. So conjugates is something that you probably have seen. You should have talked about them in Algebra 2. I think we might have used them a little bit last semester, but not too much. But they're really just a tool for part of algebra stuff. So to multiply by a conjugate, what I'm really going to do is I'm going to multiply this by 1, because multiplying by 1 doesn't change the size of anything. But I'm going to multiply it by a very specific one. The one that is the conjugate of the part of the numerator that has a square root. So in this case, the conjugate of the numerator. And conjugate just means you switch the middle term only. Square root of x minus 2 becomes square root of x plus 2. Alex, you want to join us? So again, anything divided by itself is 1. Multiplying by 1 doesn't change the size, but it will change the appearance. So now we want to know the limit as x approaches 4, and we will actually multiply these fractions together. So if you take these two terms times these two terms and you FOIL, square root of x times square root of x would be x. Square root of x times 2 would be 2 square root of x. Negative 2 times square root of x would be negative 2 square root of x. And negative 2 times 2 would be negative 4. Now, I usually skip 2 of these steps. I think I said this last semester as well, but anytime you multiply something by its conjugate, the outer and inner part of FOIL are going to go to 0 anyway, so I don't typically write that one. Now, my denominator is an x minus 4 times this mess, square root of x plus 2. And I am trying to be smart and not FOIL that together, because just like with factoring, you need something to cancel out. And I can see right now my numerator is really just x minus 4. So that stuff's ready to cancel out. And then as soon as you get something to cancel out, now direct substitution should probably work out fine. So nothing left on the numerator, so that's a 1. Plug in 4 into the denominator, you get a 4. The answer to that question is 1/4. Again, this is just a fancy algebra trick to make it look different and to get something to cancel so that direct substitution works. So typically when you see a question that looks like that, you can still try factoring if you want to, but there's a good chance you're going to have to multiply by the conjugate. Okay, so on the second example, now the square root thing's in the denominator, so what do you think we should multiply by on this one? Okay, what is the conjugate of the denominator? Okay, if you do this, and then you do this, I'm rushing here because this is all a bad idea. What did I not do? Huh? Well, yeah, I'm not finished, but I've already done something wrong. This is why I keep trying to annoy you about the first step. Your first step is still direct substitution. Just because this looks like a conjugate question, this was not indeterminate form. Notice if you plug in 3 into this, you get 0 on top and the square root of 3 minus 9 on bottom. That's not indeterminate form. 0 divided by any other number is 0. You're going to be confused, frustrated, wasting your time, all for a wrong answer. Always do direct substitution. Doesn't matter that it looks like a conjugate type of question, do direct substitution first. And I will admit that I made that mistake this morning in first period. I just jumped into it too quickly. So always check direct substitution first. Okay, so on the back page we've got like 5 of those to practice today. I didn't mention this, but just trying to get us started quickly here. I did print both of these on the same page again. This front page is 69 for the notes and the back page is 70 for the practice. The practice is not as many questions as last time, but the questions are going to take a little bit longer, as you can see from this example. Okay, the second way I'm going to show you today, I'm showing you 2 methods to deal with indeterminate form, is both of these. You can see these are trig functions, so you're going to have to think about unit circle. Sine at 0 is 0. 2 times 0 is 0. Sine of 0 is 0. This one's an indeterminate form, so we're going to have to do more work here. Unfortunately, direct substitution is not going to be sufficient. And on this one, if we plug in pi, this goes to 0. 0 times anything is 0. The sine at pi is 0. This one's also 0 over 0. You need to really make sure it's 0 over 0 first so that you don't make the mistake that's easy to do in this last question. But what's different about this one is neither of these factor, neither of these have square roots where conjugates are going to help us. So the third tool that I'm asking you to use is sometimes you need to make replacements with some of our trig identities. Now, this first example is not supposed to be one that you know. This is called a double angle identity, and you will have to memorize it someday when you get to Calculus 2. So don't worry about memorizing this one, but just trust me that sine of 2x is the same as 2 sine x cosine x. So if you knew that identity and you made that trig substitution, now you've got something to cancel, and now direct substitution should work out fine. 1/2. Okay, this one should be a little bit more fair. Again, you just don't memorize that blue part, so I don't expect you to know that. But on this question, we got 0 over 0. Again, mentally, I make a checklist of stuff to try. Factoring is the most common way to deal with this, but I can't factor this. Conjugates are a good way to deal with things, but you need a square root. And the only other method we've talked about at this point is trig identities. So you got to think about some way to rewrite some of this. I would probably pick tangent to be sine over cosine. And I don't know if you remember, but last semester the thing that I said I thought was the hardest was those trig proofs, where you tried to make one side of an equation look like the other side by making trig identity substitutions. Truthfully, this is where you really need that, so that you have some practice of thinking about how you can make this look different. And now I can see that those cancel. Sine divided by sine cancels. So really that whole mess of trig stuff just simplified to be 1. Now that it's simplified, I can try direct substitution. There's nowhere to plug in there though, so the answer to that would just be 1. Yes.
On B number 1, why is sine 2x equal to 2 sine x cosine x?
That's a double angle identity. You don't have to know that identity.
Okay.
If you're asking for a proof, you would have to know some other formulas before I could show you the proof. But again, you don't have to recognize this one, but to be honest, these question types are kind of hard to find. Like I can't just give you a worksheet of 50 of those to practice. So I have to use some like where you haven't recognized that before. Any that I ask you to do will all be trig identities. We used the depth last semester. Now, while this is up here, I want to remind you that like last class, I asked you to check 3 or 4 of them in the calculator and then the rest on the class website. But on the back page here, you're only going to have 7 questions. So here was the first one that we did. Okay, never mind. Ignore that. That's for the back page. I lied. But we can graph this and answer it from a graphical standpoint. So that's what I'm not saying that you're not going to use any factoring today, but if it's indeterminate form and it looks like this, try to multiply by conjugates. And if it's indeterminate form and it looks like this, you probably need to make some sort of trig identity substitution. Okay, I would like you to try 2 questions as guided practice here. So on the back page, if you would try question 1 and then question 6 before you do the others. One of those will have you practice the conjugate part, and one of them will have you practice the trig identity part. And I will go over both of those with you after I think you've had time to try them and see how it goes. So, of course, if we get interrupted by a fire alarm, again, this year they don't give us any specific time, so I can't really give y'all any heads up. I don't even know if it will be this class period, but if we get interrupted, we'll just pick back up and come back. I will also warn you that on these questions that you need 3, 4, 5, 6 steps. If your handwriting is sloppy, mine is also sloppy, so nothing against you if that's the case, but it does make these questions even harder. Try to make your work nice and neat and easy to follow. course, if you work a little bit quicker, you might try to check those two by graphing in the calculator or pulling them up on the website, or just moving on to another question. But I'm going to be pretty patient on these two so everyone has time to see how far they get. Okay, are you guys still working on those two? Okay, let's go ahead and look them over then. Okay, so of course the first thing you should have tried, just in case, also to be mathematically correct, plug in 3. Unfortunately, this one is indeterminate form. You can try factoring like last class, but you can tell that this doesn't factor. And then you've only got 2 new options today: conjugates or trig identities. There's no trig stuff going on here, so it's pretty obvious that it needs to be conjugate. Now, on this one, did we want the conjugate of the numerator or conjugate of the denominator? Okay, and how did you know that? Right, the square root part is the part you want the conjugate of. So the conjugate would be the square root of 2x minus 5 plus 1. Again, conjugate, you only change the middle sign. You should not be changing more than one sign. Changing more than one sign is not going to help you out. And you have to make sure that you multiply the top and the bottom by the same thing. That's the only way that you're essentially multiplying by 1 and not changing the size. So this algebraic trick, so my denominator, I've got an x minus 3 times this stuff. I'll worry about that stuff later if need be. But my numerators should work out pretty nicely because they're conjugates. Bless you. These two times these two. First part of FOIL, square root of 2x minus 5 times the square root of 2x minus 5 would be 2x minus 5. Do the outer and inner part of FOILs if you want to, but they're going to cancel out and go to 0 anyway, so I'm going to skip that. And then the last part of FOIL would be minus 1. Now, should I try direct substitution again yet? You can if you want to, but until something cancels out, it's still going to be 0 over 0. So, looking at my numerator, I say it's probably much closer to my denominator, so we still need to work with this a little bit. So, you could combine the minus 5 and the minus 1 to be minus 6. And what else could we do to that? Right, so you can still use factoring at times. You could factor out a GCF. You have to do all of that before you can see the x minus 3's cancel. And now finally that something is canceled, we should be able to plug it in and see what we have left. So, looks like we only have a 2 in the numerator, and plugging in a 3 in the denominator gives me a 2. So I believe that should come out to be 1. Now, I know you guys are going to get sick of me saying this, but this is a perfect example of how calculus can be difficult. The idea of the limit's not that difficult. The steps of this question are not that difficult. But in this case, in this problem, it's the algebra and the length of the question without making an arithmetic mistake that's difficult. Multiplying by conjugates, that's just an algebra trick. But to do that correctly and see combined like terms and see to factor out a GCF and plug that back in correctly, it just every time you add one more step it gets a little bit harder. But the calculus is not usually the issue, it's usually the algebra, the trick. Okay, and then for a quick little check here, I already have this one graphed from earlier. So here's my blue line. We were trying to find the limit as x approached 3. So just like we did last week, if you do trace 3 enter, it will jump to that part of the graph. When x equals 3, y doesn't exist, but that's okay because limits are not points. Move your cursor a little bit to the left. As x approaches 3 from the left, it looks like it's approaching a y value of 1. As x approaches 3 from the right, looks like the y value is approaching 1. So if it's approaching 1 from the left and from the right, that basically confirms all of my conjugate work there. Okay, so if you got stuck on that one or made a mistake, has everybody got what they needed out of question 1? Anything specific? How do you guys go from being too loud to too quiet? Where's the in between? Okay, question 6. So, same idea. Plug it in, hope that you're done. If not, make it look different, get something to cancel, and then plug it in. So, in this question, you probably have to slow down a little bit with unit circle, but this one is indeterminate form, 0 over 0. So our 3 tools are factoring, neither of these factored, conjugates, there's no square roots, or trig identities. So this one must be a trig identities because it's got some trig functions in it. So we need to make this stuff look different without changing its size. So from the stuff we did last semester, you can't really do much with 1 minus cosine, but you certainly can do something with sine squared. What is sine squared equal to? Very good, 1 minus cosine squared. Calculus, I'll be honest, it doesn't expect you to remember the other two Pythagorean identities very often, maybe once or twice a year, but the first Pythagorean identity is a big deal. Sine squared is equal to 1 minus cosine squared. So that's the trig identity that you have to make a substitution on, otherwise you won't be able to do this question. Okay, now these two look similar, so I know it's tempting to cancel these out, but this one is to the first power and this one squared. These are not the same thing. So, just because we couldn't start off with factoring doesn't mean that we can't factor eventually. This guy is the difference of two squares. You've got 1 being squared on the left. You've got cosine being squared on the right. And to factor the difference of two squares, one's always a plus and one's always a minus. My hint to even try that is because I know the numerator is supposed to cancel out, so I knew that somehow I was supposed to come up with the 1 minus cosine x. That just gave me a hint on my direction. Of course, it's not the full thing, but it's at least it's some push in the right direction. Then you should have canceled these out. Now that something is canceled out, you can plug it into what's left over. And if we really reduce it as much as possible, we're done. If we didn't reduce it as much as possible, we might still have 0 over 0, and we might have to do more work. But in this case, it looks like we end up with 1/4. So that means this function that I have highlighted, the y value that it approaches from the left and right of x equals 0 should be 1/4. I know what it approaches the closer x gets to 0. Once again, I already have this graphed. It's the red one. So to check as x approaches 0, I can do trace 0 enter. That point doesn't exist. That's okay. Move the cursor to the left so that we can see. Oh, I'm on the wrong function. As x approaches 0 from the left, it looks like the y value is approaching 0.25. Move the cursor a little bit to the right of 0. As x approaches 0 from the right, it appears to be approaching a y value of 0.25. So if it's approaching 0.25 from the left and 0.25 from the right, 1/4 sounds like a good answer. So, just like last class, don't use the calculator and use the graph to get your answer. You're welcome to do that to check, but you need to practice going through the motions of using conjugates and using trig identities. Okay, so wherever you got stuck on this question, is that enough for you guys to understand what you need on that one? Okay, then of course I will offer help once or twice more depending on if our fire drill is during our period or next period, but go ahead and keep on going. In about 15 minutes I'll give you a chance to ask a question or two. Looks like you only have one more, that's the trig identity type, because those are harder to find, and 4 more of the conjugate questions. So definitely quality over quantity here. Make your work nice and neat so you can read it. Try checking them with the calculator to make sure you understand what you're finding. And that will finish up this part of the agenda. And then the last part of class today, I think it would be a good idea to review your number 65, that first day of notes, for a couple minutes. And like last class, I'm asking you to get some practice in on from the first day stuff so that we're still growing in that way too. In fact, a lot of the limit stuff is going to be that way. I'll give you a little bit of new information and ask you to practice a little bit of the old information. So that will be 2 Khan Academy assignments. One where we estimate limits from tables. We did that on the first day notes, but I haven't made you practice it yet. And one-sided limits from a graph. Also practice that on day 1, and you might see that in your notes on number 65, but I have not made you practice that until today. So finish up the worksheet, check your answers, review day 1 content, and then 2 Khan Academy assignments. And 15 minutes from now, I will let you ask a question or two from the back page, number 70.
Mr. Thompson, how do you check your answer on the calculator?
Okay, so you gotta graph it.
I typed it in.
Okay. And then you're trying to find the limit as x approaches what?
4. So would you just...
Okay, so you trace 4 enter.
Okay.
Yeah. And then a little bit to left, and then a little bit to the right. Okay, there. What's on here? Okay, about 7 more minutes, and then I'll take a question or two on the board. It's been exactly 15 minutes, perfect timing. So I offered to answer or go over one or two more with you. So is there one or two that you've tried and you're getting stuck on? Yeah. Number 4? Okay. Okay, so step 1, we're going to start off with direct substitution. 2 minus square root of 4, that would be 0 over 0. So unfortunate, because they're going to have to do a lot of work here. But based on how this looks, there's no trig identity, so it's not that. It doesn't factor, so it's not that. The only other option I've given you at this point is conjugates. So instead of 2 minus that square root, we're going to do 2 plus the square root. I guess a common mistake would be only multiplying the numerator by that, but if you multiply the numerator of the fraction by something, you're making the fraction bigger. You need to multiply the top and the bottom, so it's like you're multiplying by 1. Okay, this denominator is kind of messy, so I'm going to leave it alone as long as possible. I've got an x minus 4 times this stuff. I don't want to have to deal with that if I don't have to. But multiplying the numerators together shouldn't be too bad because they're conjugates. So 2 times 2 is 4. The outer and inner are going to cancel anyway, so I'm going to skip that. And then here's a good chance where your mistake is. I would say this is a common mistake in calculus. Square root of 4x minus 12 times the square root of 4x minus 12 is going to be 4x minus 12. One's positive and one's negative, which means that these are negative, but here's what you guys often do. You often do that. And what happens is if you do that, you made the 4x negative, but you didn't make the minus 12 negative. The whole negative this stuff times positive that stuff means it's negative all of that stuff, not just the first part of it. So up in the top here, I can rewrite this. This is really like negative 4x, and then 4 plus 12 would be 16. Okay, now what can we do with this? Was that your mistake, that you didn't make this part negative? Yeah. Okay, so I'm saying that this is almost x minus 4. So if I think to factor out a negative 4, that's where you're going to get x minus 4 to cancel out x minus 4. Again, make your work. Use as much space as you need to. Don't cram it in real small or it's going to be hard to see. But the only thing left in the numerator is a negative 4. And the denominator, 2 plus the square root of 4. So I would go with negative 1. Okay, anybody else have issues with this one? Need something more specific than that? Okay, then I'll take one more for right now. Any of the others that you've tried that you thought were harder than the rest? Okay, then I will give you another chance in 15 more minutes. Again, those of you that are lucky and this is clicking a little bit quicker, you still have 2 things to do once you're finished with this, grade-wise at least. The 2 Khan Academy assignments, as you guys saw last time, those are pretty quick, unless you need to review for a few minutes, which is fine. That's kind of the point. and 67 from last class. If you didn't ever throw that in the Google Classroom, I need that so I can give you grades on it. But 15 minutes from now, I'll give you a chance to ask another question or two from there. It's been close to 15 minutes, not quite, but let's go ahead and give you one more chance to ask anything about the back of this worksheet. So 2, 3, and 5 look to be conjugate type of questions, and number 7 was a trig identity type of question.
Do number 7.
Number 7? Sure. Okay, so if we start off with direct substitution and plug in pi over 2, we would get 3 times 0 squared over 2 minus 2 times 1. So we get 0 over 0. So mentally, I'm thinking of my checklist. There's only 3 things we have to worry about at this point. There's a couple more we're going to do over the next week or two. But the first one was factoring. The numerator doesn't factor. The denominator technically does. You could at least factor out a GCF. So I don't know if I need to do that or not, but I'll try it. But this does not look like a conjugate candidate because there's no square roots. So I must need to make some kind of trig substitution. So 1 minus sine x does not match up any of the trig identities we know. It's pretty close, but cosine squared definitely has a replacement. Since sine squared plus cosine squared is 1, instead of saying cosine squared, we could say 1 minus sine squared. So that doesn't have to jump out at you instantly, but at some point you've got to try that. And then, like the other trig question I did, these two look similar, so it's tempting to start marking stuff out, but this side is squared and this side is not squared. So we got to do one more step of factoring and then we'll be on our way. Nothing factors in the denominator, but the numerator is the difference of two squares. You've got 1 being squared on the left, sine being squared on the right. Bless you. Difference of two squares, one's always a plus and one's always a minus. So that's where the 1 minus sine x comes from. That can cancel out. And so your answer comes from plugging in pi over 2 into what's left there. So that would be 1 here and a final answer of 3. As I said, I know you know that trig identity. I know you can factor the difference of two squares. I know you can reduce your fraction. I know you can plug in pi over 2 and do the unit circle. But of course, the challenge when you have to do that many things for one question, it just gets a little bit harder. Okay, does somebody else have one more I can maybe answer? Okay, well, you guys still have about 23 minutes, so if you do find a question on that, I'd be happy to help you, but you should be finished or almost finished with it. Make sure that you get that 67 turned in, and again, those 2 Khan Academy assignments should take you just a minute or 2, unless you need to look back at your notes, but you really should get that done in class as well. If you don't get the Khan Academies done in class, those will be due before start of class on Wednesday. So. And if you haven't started the Khan Academies, there's already 7 people who's finished them, so that gives you an idea of how quick they are.